Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
I feel strange being invited to speak here with all of these gods present. This is Mount Olympus, and Butler is Zeus here. And I haven't included all the gods that are here present, but speakers and some of the organizers are here. Can you see yourself there, Christian? Who is that, Hermes or something? I don't know. Anyway, you look like you're apologizing to Jennifer. I want to say, first of all, to start, that having Butler in our lab is one of my favorite things. He's still so fast and brilliant, and he sometimes protects us from the other gods. And and he's also very wise. Nobody mentioned the wise thing. I haven't known him as long as you guys have, but he's very wise. I don't know if he was wise back then, but he's wise now. He was? Okay, there you go. It's always wise. So anyway, it was great to listen and to speak. I'm not exactly sure where I fit in this picture. I figured I fit in here as the fool of Mount Olympus. Okay, so I'm going to talk to you today about some work that I did with Butler and several other people. Another thing about Butler, by the way, is he's very frank, as many people have mentioned, and he's not afraid to shoot you down when you're wrong. Do you have anything to say already, Butler, to criticize? No?
You're wrong.
Yeah. Doesn't it? Yeah?
Have you ever won an argument with Butler on the same day?
No, one of my points was that Butler's always right. I didn't know that Butler was ever wrong. So I didn't see never trade. Win, I don't want to win the argument. I want to understand what he's trying to say. So, well, but I imagine here. Yeah. I imagine here that he would have said, he's probably just being nice because I agree with him. Mount Olympus doesn't have a fool, and here I am, and then he strikes me down with a smile, as always. Okay. All right. Anyway, I should mention that this is not something that Butler and I usually work on, but we were able to collaborate on this, and we were able to collaborate with some excellent people who have worked a lot on this, including Sumit Golwani in Redmond and Rob Miller, who's from MIT here, and several very good interns, Aditya Menon, Omer Tammuz, Shubham Tulsiani, and Kuat Yasanov. So let me start by telling you about what we're working on here, which is programming by example. And we're talking about specifically text processing. So here, this is Butler, again, is Zeus. Why? What's so funny? Have you ever seen Butler without his shirt? Maybe it. Wait. Okay. Text processing by example. So seriously. So in this problem, it's one of these things. You're manipulating text, and it's really slow and annoying. Maybe you have a column of first name, last name, and you want to arrange it to last name, first initial, or phone numbers you want to reformat. Those are kind of simple tasks. Actually, Peter Lee, the reason I have this quadrant diagram here is I saw him here. I saw him here today. I said, oh, he loves these quadrant diagrams, so I better put one in. So this is not complete, I apologize, but I was able to throw it in. So you've got the simple tasks, which are like first name, last name. Complex tasks, which people have talked about for a long time, are the classic one is like reformatting a bibliography from one format to another. And now in modern days, big data is a lot of times in text files most of the time, and it's in some structured format, and reformatting it or manipulating it is very painful. And ideally, the dream is to get end users who don't know how to program to be able to do all this kind of stuff instead of programmers. And so
I think he's hoodwinked you and just took you back to his first lecture.
Oh, really? I don't even, I've never used Snowball. But is it for end users?
No.
Okay. Zeus has spoken. All right. So if you ask Butler, where we should be on this picture, he would speak and say we should be here, where create a system that end users can solve complex tasks. That would be awesome. That would be what programming by demonstration is for. I'm not quite as ambitious, so I was saying, hey, let's build a programming by example system for programmers. Okay, what do you say? And Butler says, that's the dumbest thing I've ever heard. Programmers don't need programming by example. Right? I mean, they're programmers. Well, I say maybe it could be easier to make something useful to them at first. Do you agree we would be solving the wrong problem? Well, programmers are people too, and maybe there's some value in helping them. There are orders of magnitude more end users than programmers. Programmers are the last people in the world that need programming by example. You say, well, it's kind of long. If we can't make programming by example work for them, then we can't make it work for other people. And I'm just not that confident that we can, on one shot, make things work over here in the HCI and we have to solve a whole bunch of problems in HCI and machine learning in order to make something over here. So maybe we should start something for programmers. Miller says, okay, but admit that we're not solving the real problem. For anyone who knows Butler, this night's a truth. I admit it. I don't need to win the argument. Well, watch how I win the argument. Fine, I'll collaborate with you mortals. See, we both won. So, and I'm very happy that he's collaborating with us. It's super. Every conversation with Butler, even if it's very short, I always learn a ton. So collaborating with him is really actually my favorite part about being here. So let me tell you a little bit about our STEP system today, which is in this lower right quadrant, and it's for programming by example. I'm actually going to talk a little bit about two different projects here. But before I do, I want to mention a very nice system by Sumit Gulwani in Microsoft in Redmond, which is actually in Excel 2013, and it's the largest deployment of programming by example, especially for end users. So there were many systems here that were really cool and could do a lot of things, but getting it in the hands of many people is really nice, and having it in Excel is super useful. And actually, I think Irene here told me that she was editing something in Excel. She had actually the classic example of first name, last name. It's common in Excel in a column of entries, and she just started typing in the first names, the first few ones, and Excel just filled in the other ones. And it was like magic. And that's the beauty there when you have it in Excel and you were planning on doing it by hand, and then it did the rest for you. That's just wonderful. And also, you don't have to deal with, well, do people know when it's going to work, when it's not? They were going to do it anyway. Maybe it didn't work 100% perfectly, but it saved them a lot of time. So if you want to kind of understand, just to get your head around what are the types of problems that you might solve with these systems. So Sumit was smart, and he looked at help forms. That was a very clever idea. So he went and looked at the help forms, and especially for Excel users, who are trying to do string manipulation, and he got a bunch of ideas for what tasks to solve. In our system, we looked at help forms for people writing Perl and awk programs, Python, these languages which people tend to use for text processing. Since our target is for programmers, most programmers know what these languages are. We had, for example, on our user study, we had somebody said, I took a class in Perl programming. He couldn't write a Perl program at that moment to save his life, but he had taken a class, so he knew what a Perl program could do and couldn't do. So, and typically it's for manipulating sort of structured text or semi-structured text, which a lot of the big data these days is in. Okay. There's a nice quote from Watch What I Do, which is a classic book, and in the foreword, Alan Kay says, we have macro capture systems of every kind in scripting languages, but we don't have end-user programming, nor do we have programming by example. The range of aspiration, so now he's talking about which tasks we should solve, the range of aspiration should extend to at least the kind of applications purchased from professionals. So I think you can correct me, that he's talking about the kind of, you want to have eventually programming by example for these tricky problems, which is something that's really hard to do, because programming is hard. Getting end users to do it is very hard. So I've talked a little bit about the target audience and the task domain, and then I'm going to talk about two papers, both of them joint with Butler. The first one is about structured programming by example, and the second one is about machine learning. And then I'll conclude. Okay, so I'm going to start with a task here. Somebody's doing a task. Picture this, they're doing a task at the keyboard, and try to figure out what they're doing, okay? So here I am, da-da-da. Move my cursor over here. This is programming by demonstration, actually, where you get to see me do it step by step. Okay, raise your hand if you have some idea of what you think the task is I'm doing. Okay, so one person. So this was not a great success in two people. What do you think it is?
Any single character you're surrounding by dollar signs?
Well, there's this character here, which I didn't surround by dollars. But that was very, very close.
Which one? I don't see it.
This one.
Oh, sorry.
Yeah, these are single. You're right. These are single characters. You're very close. These are single characters surrounded by dollar signs, but that one I didn't surround by dollars.
Single characters that are not already surrounded by
Wow. Oh, that's good. Well, that's actually very close, but not quite right, okay? But maybe does Leslie Lampert have an idea? Okay, so this is a LaTeX file. I just changed the fonts, actually. That last font was Wingding, and this is regular Times Roman. So all we're doing is we're putting $ around single characters that are not already between $signs. But it's a bit more subtle in it. This task was actually given to me, not in a help form, but by a friend who runs a journal. And he was getting a lot of submissions, and he said, we want to automatically add $signs to single variables. Now, that's how he phrased the task, actually. It wasn't well defined. So that means roughly putting $signs around things that are not already between $signs, already between begin math and begin a line, end a line. You know, there's like 100 different ways in LaTeX, for those who know, to demarcate math. And what about the lowercase a, which is a word in English, or capital I, an I word. So it's actually, you want a system that will help you figure out how to do this as best as possible. You don't even know your task ahead of time. But the point of this example was it's very hard to communicate this example by example. Only one person got it, and even that definition wouldn't have been satisfactory for him and his system. Okay? So what's going on here? So one of the things that Butler says is that, it's not a joke, is that when things don't work, you don't want to have the user just doing it over and over again. Okay? The user has to have something else to do. So in this example, what should we do? I mean, the user is going to go add $signs here, $signs here. What can the user do besides just keep going and going? You have any idea? I mean, it's like somebody described it as like trying to fix a clock. It's not working, and all you can do is shake it. You know, you need something more transparent so you can communicate to the computer what you're trying to do, and the computer can communicate back what it's doing. Does anyone have an idea what you should do?
If the computer gave you feedback about what it thought the pattern was, and then you could go and find counterexamples that showed it what you were looking for?
Yeah, so exactly. It's a question of feedback, and sort of the idea is that you want to also enrich the representation, because there's structure here. In this example and in the tasks and the help forms, many of them have a very rich structure. And without being able to expose that structure, you can't, I don't even know if I could do it just through examples. I mean, you need to expose the structure. The computer needs to be able to have a notion of what's in math mode, what's not in math mode, and so on. So that's what we do. And just to give an example, in the classic example, you have the bibliography. Obviously, there's a huge amount of structure here, where you have, records are entries. Each entry has author lists and authors and years. And then, if you really want to reformat a bibliography correctly, you need to know what are books versus articles versus so on. So there's a lot of structure there. And this is represented in our system. I apologize, I chose the colors. I don't know why I chose the colors for this project. I'm colorblind. Anyway. Okay, so so now let me give you a little demo. I think that will be helpful. This is a great chance for a failure, which will be much more fun than if it succeeds, right? So, okay, so here's our system. I've already put the program here. You can't see it, but essentially, let's see if you can, is this big enough to see, to read it all? Oh, that's too big. Essentially, we have a list of fonts here. Can you guys read it, or is it too small? You can read it? Okay, there we go. So the beginning, it's just a list of fonts. Each font has a name, a style, and a bunch of other stuff. And the goal in this task, this is one of the tasks from the help forms and from the user studies, the goal is to sort the fonts and group them by their style. Okay, so all the bold fonts should be listed here, separated by semicolons. So here's the beginning, here's the end of the script, and then the steps in between, you're essentially adding colors and marking it up. Okay, so you're kind of manipulating it, and I'll do that a little bit. But you're kind of wrangling and adding these colors all by example. Okay, so that's kind of what we'll do. So let's go ahead and try it out. So I'll take the data, I'll copy it, I'll paste it into the web page, click Start a New Script. Okay, so now each step in this program is illustrated by a mock input on the right and a mock output on the left. I'm going to take two records, let's say, and copy them down into the mock input and mock output. And the first thing I'm going to do is I'm going to mark them in red, which we'll call font. So the font name we'll mark in red. So in the mock output, I say, okay, these are both fonts. And then, okay, let me go to, I click auto code. And feel free to interrupt with questions, by the way. I'd rather have questions during my talk when it's not clear than at the end. So you get a bunch of choices. Some of them are right, some of them, well, in this case, one of them is right. Here, this one looks right. Oops. Let's see what the other one is here. This one's wrong. Okay, so I can see that the third one is right, so I take that. Okay, and now again, I'm going to mark something. Let's mark, in this case, the records, because there's this great hierarchical structure. And the second color we'll use for records. Green. Okay, and we go. We add records. Okay. And sure enough, it seems to work. The first one looks good. Second one looks terrible, so we choose the first one. And the next one's going to be a little more interesting. We'll add styles, okay? And you'll see why it's more interesting. So we choose the blue color for style. Again, we choose 2 records. If you ask how many examples to use, try 3. Unless you used it a lot, then you can try 2. If you really know what you're doing, you can sometimes use 1. Okay, so we say styles. This time, it's not going to work. So what happened is that both of our examples had regular. And so the computer, I could blame my interns, didn't generalize correctly and said, oh, I think what you're doing is highlighting all the regular. So you have 2 choices. You can go look for another example which is not regular, or you can do something cool, which is you can play with it here. So the computer is trying to figure out what function maps the mock input to the mock output. So let's just change the mock input and mock output. They don't actually have to be real examples. And maybe this is even better, because what if the style doesn't start with a capital letter? What if the style has a lower space in it? I don't know if there are any styles like that, but I want my script in the end to be able to work for those things. So let's try that. That didn't get it right, but we go looking for a program that gets it right. There we go. Yeah, okay, so the fourth one in this case works. We used to show people carefully the functions we generated, but we found they just looked at the data much more. So, okay, so you get the idea, and then I won't go through the entire example, but I'll go maybe a couple more steps. So, you delete a bunch of stuff, because all we want, remember, is all the fonts and the styles. And that's a pretty easy routine. And then the next step is sorting by styles. Okay, so we're going to sort this entire list by styles, which is fun, because sorting by demonstration, think about it. How do you sort by demonstration? But having this little mock input example is pretty good for that, because you say, well, you just choose some unsorted region here, and you say, okay, what function maps this small set to this small set? And that's pretty easy to figure out. Sort records by styles in alphabetical order, okay. And then the only other thing I'll show you maybe is this other cool step, which we were happy with in our user study. We didn't teach our users how to do this, but there's another step here which is very natural, which is maybe we'll call this color style set. You need to create a set of, for each, we'll put all the records of the same style together in groups. So here let's choose the bolds and the bold italics. And then I'm going to put these guys in a style set together. Oops. Okay. And so what I did is I said, oh, let's put these 2 things, because they have the same style, in one color. And these guys are not, and these guys are in the same color. And one of the things that happens here, which is nice, is that since I've done this before, I know what happens, but the computer didn't exactly do what we wanted. It actually put a style set around each individual style, which is not exactly what we want, but that's progress, so let's take it. Actually, maybe it's better than what I asked for. So that's just an example of where you get what you get. Sometimes you do better, and then you continue on and move on. So you get the idea, and that's the demo of this system. And we ran a user study where we took grad students and postdocs who knew how to program to different degrees, and they were able to either program using their language of choice or use our system, and they did better using our system. I think they liked it more, and they completed them faster and more tasks. Okay, so basically I talked about these first 2 things. I'll just have maybe one slide on the features for programming by example of machine learning. So let me just skip even, this is okay, let's just skip ahead to the step of interest in this program. So here's a simple step that somebody might want to do. You have a list of authors, and you want to count how many times each author occurs in this list. We've already sorted it alphabetically by last name. So it seems like a pretty simple operation to any person. You could probably figure out what they want. But it's like, it's a program. I mean, you got to learn these programs, and these programs, there's infinitely many of them. And how do you search for them? And you know, even programs of a small size, there's exponentially many of them. And there's not much to do about that. I mean, there's still exponentially of them. I don't think you're going to avoid that totally, but you can use machine learning to search faster for them. And so what we did in this other paper is we looked for features of the data. So the features here, I'll just tell you what the features are. I won't connect them to the machine learning algorithm. But notice that, for example, there's numbers in the output and no numbers in the input. And when that happens, that suggests that you might be counting. It's not at all a promise, but the counting is a little bit more likely than other functions. The counting is already in the library of functions. Parentheses are in the output and not in the input. Well, gee, these parentheses constants might be useful. You're not going to just start generating all constants in the world, but ones that are in the output and not in the input, multiple times especially, might be very useful. And there's duplicate lines in the input, but not in the output. Okay, so that suggests maybe a dedupe function, which is sure enough in there. So that was kind of another project. So the point is that in this programming by demonstration, it's really a challenging problem. There's search, there's HCI, there's so much to do, and you want to possibly make it work for programmers, but ultimately it boils down a lot to representation and having good features, and that's something that's in common across the machine learning and the HCI part. I'm over time, so let me skip the conclusions and just say happy birthday, Butler. Thank you for always being brilliant, which you are, and frank, which is great. And you're right. I thought he's right. I guess it's nice to hear that I should try to argue with him and maybe win an argument. I never thought of that strategy. It didn't occur to me. And also, thank you for being a friend.
I should just say that when Adam and I argue and we don't agree, he goes his own way.
Yeah, I don't have to do what he says. I just don't need to convince him that I'm right.
That's what Adam does with everyone.
I learned that from my wife.
I actually did want to see the conclusions.
What'd you say?
I actually did want to see the conclusions.
Oh, the conclusions. Yes, it's more or less what I said, which is of these two things, which is that the system we developed is a text processing system for people who know how to program right now initially. And our goal is to move to these end users. And as I said, it's sort of a combination of these challenges in interface design and machine learning. And machine learning, we all know you need the right features to get something to work well in machine learning. And in this case, since it's a problem that we can design away, we use HCI to really generate those features.
What about the system that you presented to us is particular to programmers? To me, it seems like something that even anybody else in my family who are all completely non-technical could probably figure out with a little guidance.
Oh, thank you. Well, I mean, there's part of this is actually you are programming. I mean, somebody takes a task, they have to think about how to break this task into steps. So that in itself is the beginning of programming, but I guess you have to do that even when you bake a cake. I mean, okay, yeah. You have to do that always. But I do think that, well, we did some experiments with non-programmers, and they looked at colors and they started talking about rainbows. And so I'm not sure how much more work is involved, to be honest, but what'd you say? But there's so much going on. I think we need to, the programmers were much more tolerant, let's say, of when our system wasn't working, or think creative about coming on workarounds. You can usually find workarounds. If it's not working, you could add more colors. And they were very fluent in just coming up with solutions one after the other. We didn't experiment on it that much with non-programmers. We started down that route originally to try to understand how they would think about these colors and stuff. And it was so hard that we just said, let's try it for programmers, and that went so easily. Okay, thanks.
Other questions? All right, if not, let's thank Adam again.
Thank you.
It's quite amazing how this happens. Never seen a workshop finishing 20 minutes before its time, but Christian will probably cover for all of this time that we have excess.
No, I really don't want to cover for all this time because, as we learned, there's cake outside, and we will, soon after I finish my few remarks, go and
have a champagne and toast on Butler, which I think will be the most important part. So we learned a lot about Butler, right? He is stubborn, he's fast, he often uses the word bogus, and actually, honestly, sort of, I have not the sensitivity of a native speaker, so these words he usually uses don't bother me. I can tell you he never uses the word bogus. But he's definitely always right, or at least on the first argument. And as Jennifer said, he has a lot of style. I learned that immediately when he moved in here in his office. He was the first to actually, it was important for him to first hang up his art before he got his books in and his patent cubes and things like that. So he definitely has style. And what we learned from all the speakers today is he's really well loved. And so I want to thank all the speakers of today and I want you to join me to thank the speakers for all the talks and telling us a little bit about Butler. Okay, and I think we should thank the organizing committee. I mean, Jennifer and I want to thank the rest of the organizing committee who really did all the work. So Barbara, Chuck, and Madhu, thanks the three of them. And finally, there are sort of the invisible people behind the scenes who always help. Irene, Lauren, I don't know whether Lauren is here, I see Irene. And last but not least, Jessica, who really does sort of a super professional job. She came in from Redmond for that, and without her, half of you wouldn't be in hotels, because just like Butler, you might not book your hotel when you come to a conference or things like that. So thanks the three of them for this. Okay, and with that, let's enjoy the champagne and the cake.